Number 6, I did the first derivative for you yesterday. So this is what number 6 looks like with the first derivative. You got 3x squared minus 12x plus 3. And I do want to make a comment here about the sign analysis because people are asking me what to do as we were leaving yesterday. So you have this for your first derivative. Obviously, you can factor out a 3, but then you look at this and you notice this will not factor. So then you had to use quadratic formula. And let me just go ahead and fix that. That's a negative 4. I don't know if you can see that, but I think most of you. That's a negative 4 squared. And then when you did the quadratic formula, you get it down to 4 plus or minus root 12 over 2. Let's just pretend you didn't have a calculator, because you probably wouldn't for this one. I'm pretty certain you would not have a calculator for this. So people always say, well, you tell us we don't have to simplify roots. You're right, you don't. But in this case, it would be to your benefit to simplify the root, so you kind of know what the decimal value is. So you get 4 plus or minus root 12 over 2. And then you get 4 plus or minus 2 root 3 over 2. And then you get it down to 2 plus or minus root 3. So there's your critical values for your first derivative. So when I do my first derivative, my sign analysis for my first derivative, okay, it's going to be from negative infinity to 2 minus root 3. And I know that that one's smaller than 2 plus root 3, obviously. And then I'm going to have 2 minus root 3. So I'm going to have 2 minus root 3 up to 2 plus root 3. And then I'm going to have 2 plus root 3 to what? Infinity. Now, what I would do is if I'm on the AP exam and I'm having to deal with like a root 3, because they're comfortable dealing with any fraction from negative 1,000 to 1,000. They're comfortable dealing with really simple roots like root 3 and root 2 and root 10 and, you know, anything under 100. Like if they give you root 79, they're going to want you to know that root 79 is 8 point something because it's between root 64 and root 81. Like they're going to, I doubt they're going to go that high. It's probably going to be something like root 2 or root 3 realistically. So when I look at this, I'm like, okay, this is 1.73 approximately. So what I would do is just say, okay, 2 minus 1.7 is approximately negative 0.3. So then I know what I'm working with here. I just did an estimate. Okay, they're not going to look at this work. This is just for you. And then 2 plus 1.7 is going to be like approximately 4.7. And so then you're like, okay, now I know where my test values are. I'm absolutely certain I know where test values are going to lie. So I'm going to test 0. Well, actually, it's a parabola. The first derivative, since you're doing a sign analysis for the first derivative, this is a parabola opening up, so I know it's going to be plus, plus. Or you can do your test value of 0, and if you test 0, this will 0 out, this will 0 out, and you'll just get plus 3. Okay? Which will be, wait, did I do that right? If I test 0. Oh, hold on just a second. You have to be very careful here. So I got 2 plus or minus root 3, correct?
Yeah.
Tell me what I'm doing wrong here, people. Does everybody agree it's a parabola opening up?
Yeah.
So it's going to go positive, negative, positive. Agreed?
Mm-hmm.
Okay, tell me why when I plug 0 in, this thing's not negative.
Does it bounce?
We're testing the derivative. I took a 3 out, right?
Yeah.
I got x squared minus 4x plus 1. Is that correct?
Mm-hmm.
Let me see your calculator real quick. Why is my signs right? Somebody check my signs real quick. Just look at it real quick while I do this. Minus 12x plus 3. Graph it. Definitely goes below the x-axis. Zoom 6 it. Oh, 2 minus root 3. Mr. Morris is really good at estimating. 2 minus root 3. Y'all should have stopped me on this one. Good gravy, Mr. Morris. 2 minus root 3 is 2 minus 1.7's positive 0.3. Okay, this would be positive 0.3. So 0 is not in this interval. Where's 0 going to lie? In the first one. So yes, that's right. So it's positive. Okay, so if I plug in 0, I'm going to get a positive 3. So yes, that's positive. So I tested this one right here with 0. All right, my fault. So then this will give me increasing, decreasing, increasing, and then you're going to say you're going to have a max here at 2 minus root 3 and a min here. And when you plug these in, just so that you don't have to do it by yourself, you have to plug in literally 2 minus root 3 to this. So at that point, it might be beneficial to have that multiplied out. Did anybody actually multiply this out? FOIL this out by any chance?
Yeah, it was x cubed minus 6x squared plus 3x plus 10.
Minus 6x squared plus 3x?
Yep.
Minus what?
Plus 10.
Plus 10?
Yep.
Okay, and since it's a dumb value, I'll let you use your and I'll tell everybody in class today on number 6, you can use your calculator to plug that in, the 2 plus 3 and the 2 minus 3, and let's just do a decimal on this one. So number 6, let's do a decimal for the relative maxes and mins and you know, I mean, you can say increasing, decreasing on the intervals, but when you go to the relative maxes and mins and you actually have to plug them in, I'll let you plug in on your calculator. So you're going to go, you know, 2 minus root 3 cubed minus 6 times 2 minus root 3 squared plus 3 times 2 minus 3 plus 10. Or you can plug it into y equals and just go to the table and type in 2 minus root 3. And I'll show you something better instead of changing the calculator to ask, because I don't like doing that, because then you have to go back, because sometimes I want to see the whole table. So my recommendation is, what is it, x to the third? X to the third, tell me what it is.
Minus 6x squared
Minus 6x squared
plus 3x
plus 3x
plus 10.
plus 10. Here's my recommendation is, I haven't taught you this before, but it's pretty darn slick. If you press graph, I'll have to zoom 6 it. If I press graph, if you just press second trace and you do number 1 value, and you just type in what you want, 2 minus root 3. Oops, sorry, I got to do that again. 2 minus root 3. It'll give you the value. Instead of changing your table always to auto ask, you know, the ask, second trace 1 does this for you. Okay, so you could do 1. So it would be, so 2 minus root 3 ends up being, you know, the 0.26. So 2 minus root 3 is right here. That's where your critical value for your first derivative is. That's where you peak out. So your slope of your tangent line is 0. That's where the critical value for the first derivative is. So that 2 minus root 3 is 0.26795. I said it was approximately 0.3, but this is the exact. And then when you plug it in, you get this. So use this as your relative max. And then to do your relative min, you can do second trace again, and option 1, and you can go to plus root 3. And then you'll get 3.732, comma, negative 10.392 for your relative min. And again, you could do this from the home screen. Some people don't like, you might not remember that, but you remember how to do vars, y vars, function, y1, and just type in the 2 minus root 3. And then close the parentheses. And then do, just copy it and then just change that to a plus. So you get 10.392 and negative 10.392.
I forgot to Rick.
Yeah. And then what Ellie showed us how to change the table to auto ask. Change it from auto to ask instead of generating a whole table. Like right now I've got it on that stupid auto ask. I don't like this at all because I want to see the whole table, so I never use this. But you can certainly do that if you remember to go to your table and change it back to auto. See, I like seeing the whole table. But the disadvantage of seeing a whole table is you can't get to 2 minus root 3 or 2 plus root 3 is the only problem. So I use the second trace, number 1, or I just go to home screen and do vars, y vars function, y1 is the way I do it. Okay, let's do one with a double root real quick, and then just let you see if you have any other questions, if you want me to check something or whatever. Which one has a multiplicity 2 early on? 7 does? All right, let's do 7. That sounds like a good. And then there was another one that had a multiplicity 2, number 4. Number 4 has a multiplicity 2, so make sure you check that one. Okay. Okay, number 7. Is this one you want me to do? You don't have done that you know.
Oh, we did it, but we got stuff wrong, and we couldn't figure it out where we went wrong, so.
All right, here we go. So domain, don't forget to do domain and range. Domain's all real numbers, range. This range is going to be a little bit different because it's a x to the 4th power. So it's actually going to bottom out somewhere because it's opening up. So the absolute min, it's going to have an absolute min, which we're not required to find. It's just one of those relative mins is actually going to be the absolute min. And the absolute min is what you're going to base your range off of because that's going to be the lowest point on the graph. So first derivative. So we're going to get y prime is going to be equal to 12x to the 3rd plus 9x squared. So there's my first derivative. Now I'm going to do CVs for the first derivative.
4x to the 3rd.
What?
It's 4x to the 3rd and 7. That's 3x to the 4th plus 4x to the 3rd.
Oh, this is 4x to the 3rd?
Yeah.
Okay, sorry about that. Sorry, I wrote the problem down wrong. Okay, so that would be 12x squared also. Okay, kind of nice because then it factors. Okay, CVs for y prime is where y prime equals 0 or undefined. Again, on these polynomials, we never have to worry about undefined, do we? Because that's differentiable. Okay, the reason we're not getting undefined is because polynomials are all not just continuous, they're differentiable. Okay, so now I'm going to set the derivative, get away Siri. I'm going to set the derivative equal to 0. So I'm going to go 12x to the 3rd plus 12x squared is equal to 0. I'm going to factor out a 12x squared. That's going to leave me with x plus 1. Okay, so you get this two things, 12x squared. The 12 really doesn't matter, so I'm actually not going to bring the 12 with it. The 12 is just a constant. So if you set x squared equal to 0, if you take, the reason this ends up being multiplicity 2 is because you take square root of both sides, you get a plus or minus, which technically is 2 different roots, but there's no such thing as positive 0 and negative 0. They're both the same. So that's why it's multiplicity 2. Okay. So this is multiplicity 2, or what we call a double root. And this is x equals negative 1, and that'll be a multiplicity 1. So sign analysis is not going to switch at 0. So when we get to 0, we can't change signs at all. Okay, so there's my critical values. I don't care if you label the multiplicities, that's up to you. I do, just so I don't forget to switch to sign analysis. So my SA for f prime is going to be negative infinity to 0. It's going to be 0 to 1, and then it's going to be 1 to infinity. All right, let's test. Oh, it is, isn't it? Man, tell you what, I'm screwing up. Good catch. It's negative 1. So it'd be negative, good catch before we went too far. Negative 1 to 0. Careless mistake, so stupid. 0 to infinity. Don't let me make any more of those. All right, I would test. It is an x to the 3rd power. Most of you can look at it and say it's going to be up to the right, down to the left. But if you want to make sure your test value and use the fact that it's going to alternate and not change at 0, just test one of them. I'd probably test 1. If I plug 1 in here, 12x squared is always going to be what? It's all, because you're squaring it. It's always positive. So you don't even have to look at this. This is always positive. So you plug 1 into this, you get a positive 2. A positive times a positive is a positive. It will not switch signs at 0. So at 0, it does not switch signs. But it does switch signs at negative 1, and that does agree with the fact that it's supposed to be down to the left, up to the right. So it bounces at 0. So we've got, this is my f prime. This tells me that f is decreasing, increasing, increasing. We do have one relative extrema. We have a relative min, that's it. There is no relative max. So then we're going to have f is decrease from negative infinity to -1 because f prime is what? Negative. And then we have f is an increase from, and technically you need to say -1 to 0, union 0 to 1, because at 0 it's actually not increasing. It's a critical value. It's a slope of 0 there. So I know it's positive over this entire interval, but this is a critical value. So at 0, for just a moment, it has a slope of 0. And that's because f prime is what? F prime is positive, so I can block that off. And then we have a relative what? Min at -1 what? I'd have to plug -1 into the original. That's going to give me a +3 and a -4, which gives me a -1. So relative min, and I always plug in the OG. Because f prime goes from what? Negative to positive. That's first derivative test. First derivative test is when you check how the signs are changing to determine relative extrema. I might as well finish this one for you since you came in early, so you can have it just done. So second derivative, what would second derivative be?
No, 36x squared.
36x squared plus what? 24x. I can factor out a what?
12x.
Block off my second derivative. Set my second derivative equal to 0. So I get 36x squared plus 24x is equal to 0. Factor out a 12x, I believe. That'll leave me a 3x plus 2. I get two critical values this time, CVs, for f double prime is x equals 0 for this, and then -2/3 for this one. So there's my CVs. Now I can do my sign analysis for the second derivative. They're all multiplicity 1, so they're going to alternate. So we're going to go from -infinity to -2/3. We'll go from -2/3 to 0, and then we'll go from 0 to what? Infinity. I'm going to test 1 again. 1 is way over here. Or I can know it's a parabola, it's opening up, so it's going to be positive at both ends and negative in the middle. But if I test 1, just to be sure, 1 makes this positive, 1 makes this positive, so it's positive, negative, positive. That agrees with the fact that it's a parabola opening up. So f double prime tells me that f prime is increasing, decreasing, increasing. That'll be more important next week. F then is concave up, concave down, concave up. That's what I'm after. So I'm going to say f is concave up from -infinity to -2/3, union 0 to infinity, because f double prime is what? Positive. Then I'll say f is concave down from -2/3 to 0, because f double prime is negative.
You have to say it's negative and positive, or because it changes sign?
No, that's POIs. Good question. POIs is where you say it changes concavity. Concave up, concave down is based on if the second derivative is negative or positive, or the first derivative increasing or decreasing. So saying it's concave up, you have two ways you could say it. You could say because the second derivative is positive, or because f prime is increasing. Because if f prime is increasing, then f double prime is positive. You can say it's concave down because f double prime is negative, or f prime is decreasing. Because if f prime is decreasing, the second derivative is negative. So that's by definition what concavity is. Usually the simplest way is just go two derivatives away and look at the signs. And then concavity changing is where you get POIs. And we do have two places where the concavity switches, and And also make note here, the domain was all real numbers, so these are actual points. They're not undefined values. So there are actual points at negative 2/3 and 0. So I'm going to say there's a POI. Oops, sorry. And you can include both of these. You can say a POI at negative 2/3, comma, whatever, and 0, comma, whatever. And you can say because concavity changes. Or, actually, that's not the way I like to say it. I say because F double prime changes signs. Or you say F changes concavity. Okay? So negative 2/3, what do you get when you plug it in? Might as well figure it out for you guys. It's got to go to the original. It's going to kind of suck. 0 will be easy. 0, 0, right? Let's see. Is it 3x to the 4th?
Yeah.
So if I plug this into the original, 3x to the 4th plus 4x cubed, was that it?
Nope.
So it'd be y is equal to 3 times negative 2/3 to the 4th plus 4 times negative 2/3 to the 3rd. I'm sure some people use their calculator, but just know you won't have it on the AP exam. It's fine. I don't care if you do. What is that going to be? 16 over 81 plus negative 32 over 27. Is that right? And then that 3 will go into this 81 27 times. So I'm going to have 16 over 27 plus negative 32 over 27. So I get negative 5 over 27 is what it is. Is that what you guys got?
No, we plugged it into the.
Original.
Yeah, that's, we did it wrong.
Oh, yeah, plug into the original.
We had everything right, and then we did that one part wrong.
So let your partner know.
Yeah.
And now we can graph it. Now we can make a pretty graph. Pretty graph, pretty bird, pretty bird. So tell me all the points we can plot.
Negative 2/3, negative 5/27. 0, 0.
Oh, I did not want to come to school today, but I came for you guys, is it?
Oh, thank you.
All right. What are all the points?
Negative 2/3 and negative 5/27 is 0, 0.
So we got 0, 0. That's a point of inflection, right? Now we're done first and second derivative test. It's one problem.
One whole problem. This is too much.
Too much.
When do we ever have to do this?
All right, what's the other one?
Negative 2/3, negative 5/27.
Negative 2/3, negative 5 over 27. That's probably about right here, would you say? If you had to eyeball it.
Yeah.
Okay. Give me another thing. What else do we got? -1, -1. Oh, wow, that's sweet. Is it like that right there? Any other points we have? All right, tell me. It starts out, it goes concave up, concave down, concave up. So if I just kind of look at this, I know it's going to start out, I already get a good idea. It's going to be concave up, then it's going to be concave down, and then it's going to be concave what? Do you see it? Because the POI is at 0, 0. Oh, wait, hold on. It's concave up until negative 2/3. Sorry, it's concave up to this one. Okay, it's going to be concave up to this one. Then it's concave down, and then it's concave up again. I get a good idea of what it looks like. And I think it does start out decreasing, right? And then it's concave up until I get to here. And then it's got to switch to concave down. And then it's concave what again? There you go. And notice, remember I told you in the first derivative, it has to, even though it's a, I thought one bounced.
Yeah, it bounces up 0.
Where does it bounce at?
0, 0. Does that one C2?
Oh, this is the original function. The derivative bounces.
Yeah.
The derivative bounces. Which is actually interesting because when you get this horizontal tangent here, this is actually in the first derivative. In the original equation is what you call a a multiplicity 3. Anytime you get that disco curve looking thing and you get this horizontal tangent on the x-axis, that's a multiplicity 3 in the original equation, which when you take the derivative becomes a multiplicity what? Becomes multiplicity 2. Okay? So there you go. You got that one all done. What's the range now? What's the range?
Y is greater than to -1.
Yeah, this right here. That's the lowest point. So your range would be from -1 to what? Infinity.
Does it matter how we value?
You could go y greater than or equal to -1 if you want. Imagine that's what some people did. Okay, is there anything else? Otherwise, I'll just let you kind of work, and if you got an individual question, I can certainly, I'm going to have some kids coming in from other classes too, but I just wanted to kind of hit some things. I am going to go over 14 and 17 in class today. And then whatever work time we have left, I mean, that's going to take like 25 minutes, and then you can have 25 minutes more of work time. And then you